So today we're going to look at graphing exponential functions and something that undoes those exponential functions. And just to relate it to more of something concrete maybe in your life, as a society we're accustomed to performing an action and then undoing or reversing that action. So if we put on a jacket, what undoes that? We can take off the jacket. Or if we open a door, what undoes that action? We can close the door. And we have the same kind of idea in mathematics as well. We have operations that undo each other. So if we add 5 to a number, what undoes that process? Subtract 5 from a number. Or if we multiply a number by 4, what do we do to undo? We divide a number by 4. Maybe a little bit tougher one here. Squaring a number. What undoes squaring? Oh, you knew it. Excellent. Square root. And then distributive property. If you think of that, what distributive property looks like is it might look like something like 4 times x plus 2. And remember, distributive property, we would multiply the 4 by that. So what undoes that? Well, actually, what undoes that is that we would have to factor. But when we talk about undoing, undoes, which I'm not even sure is a correct English word, but what that is called in mathematics is it's called working with inverse operations. Addition and subtraction are inverse operations. Multiplication and division are inverse operations. Squaring and taking the square root are inverse operations. And I'm going to skip over example 3 for now and move on to 4. We've talked about inverses before, and what's the process for finding the inverse of f of x equals 4x minus 11? Do you remember what the first step is? Well, the first step is that we're going to write f of x as y. Instead of f of x, we're going to write it as y. Does that give you strike a little bit in your mind of then what we have to do next? What do we have to do next, Bradley? Switch the x and the y. So x is going to go where y went. Y goes where x went. So it's going to be x equals 4y minus 11. So once we remember that, then we can finish this by solving for the value of y. So we're going to add 11 to both sides. And we end up with x plus 11 equals 4y. And then to finish, it's 4 times y, so our inverse operation is going to be to divide everything by 4. And I'm just going to leave it like that. Our y, or our inverse here, is x plus 11 divided by 4. If you prefer, you can write it as x divided by 4 plus 11 divided by 4. It means the same thing. But what we're going to do is we're going to verify that these two are inverses. To remember what the rule is that we have to use to verify. Well, the rule that we need to verify is, I'm going to write it as f of g of x equals g of f of x. And what do we have to equal when we figure out those values? Jordan? They have to equal x. They have to equal x. So I can't fit it in on their line, but it has to equal x. So let's practice again how we verify those. And once again, our original function was f of x equals 4x minus 11. And instead of calling it f to the negative 1 of x, which is our inverse notation, I'm going to call our inverse g of x equals x plus 11 divided by 4. And what we're going to do to figure out these two values is we're going to take the blue equation and put it into the green. We're going to take the green equation and put it back into the blue. And when we simplify those values, we should end up with x. So once again, we have to figure out what f of g of x equals. So we're going to fill in g of x. And g of x is x plus 11 divided by 4. And we're going to put that back in for f. Back into the f function. Get that said correctly. So the green part of our equation is going to replace the x in our blue. So we're going to be left with 4 times x plus 11 divided by 4 minus 11. When we simplify this, it's 4 times that value. The 4's cancel out. There's a 4 in the numerator, there's a 4 in the denominator. And now we're left with x plus 11 minus 11. And what does x plus 11 minus 11 equal? X. It equals x. And that's what we want. F of g of x equals g of f of x equals x. Now we're going to go the other direction here. And we're going to figure out, well, what does g of f of x equal? So now we're going to take the blue part of our function and put it in for f of x. It's 4x minus 11. And we're going to take that blue value, and wherever we see x in our green function, we're going to replace it with that blue value. So it's 4x minus 11. That's going to go in for our x plus 11 divided by 4. Don't skip steps. The first thing that we need to deal with is the minus 11 and the plus 11. What does negative 11 plus 11 equal? 0. They cancel out. So now what we have is we have 4x divided by 4. Don't skip that step. And then finally, what does 4x divided by 4 equal? It equals x. The 4's cancel out. 4 divided by 4 is 1. And then we verify that our inverses, that we do have inverses, because both of those functions ended up to equal x. So if we flip our page, when we originally found inverses of this function this year, what we've been doing, we just did it a minute ago when we had f of x equals 4x minus 11, we switched the x and the y values. Well, now here, what we're going to do is we're going to graph the inverse here in a moment. But beforehand, let's go backwards to what we did last week and when we were graphing exponential functions. And I think I still have this typed in to the calculator. But we can go back and we can type in 2 to the x power. And then when we do that, we can go to second and table, and we can come up with our values on there. Well, -2 is 0.25. And -1 is 0.5. We are reading off our table. Then we have 1, 2, 4, 8, 16. Strictly reading straight off our calculator, we did 2 caret x, x comma t comma theta comma n. And now we're going to draw the graph here. And hard for me to get this in accurately. I'll do the best I can. But it's -2 and then 0.25. -1 and 0.5. 0, 1. 1, 2. 2, 4. 3, 8. 3, 8. Try again. And then 4, 16, which just goes slightly off our graph. For f of x, there appears to be an asymptote. Where? Right? Where? So is it x equals 0 or is it y equals 0, Matthew? It's y equals 0. So it's right here. There's our y equals 0. Now what we're going to do now is we're going to take those values that we just found and we're going to fill in the table below for the inverse function. And just like we said, for the inverse here, we're going to switch the x and the y. So this point becomes 0.25, -2. We switch. 0.5, -1. 1, 0. 2, 1. 4, 2. 8, 3. 16, 4. We took our original function of 2 to the x, and we switched all of our values, and now we're going to graph those. 0.25, -2. 0.5, -1. 1, 0. 2, 1. 4, 2. 8, 3. 16, 4. A little bit off our graph. And we could have typed that in the calculator there. No, we couldn't have, but we got those values from originally typing that into there. There happens to be another asymptote in this graph now. And for our blue graph, what we ended up with is we ended up with y equals 0. What do you think the asymptote is for the red graph? Jordan? X equals 0. It's going to be the y-axis this time. One more thought about this picture here. These two functions reflect over the line y equals x. What that means is, if we draw in the line y equals x, which goes from the bottom left-hand corner to the upper right-hand corner and through the origin, if we folded our paper along that dotted black line, the red graph would land exactly on the blue graph. And now that we've seen one, let's try another. If you would like, you can type it into your calculator, but for time purposes, I'm not going to type it in. F of x equals 3 to the x. Well, 0.11. 3 to the negative 1 is 0.33. 3 to the 0 is 1. 3 to the first is 3. 3 squared is 9. And again, you could have typed in 3 caret x in your y equals function. And let's draw our picture. Negative 2, 0.11, negative 1, 0.33, 0, 1, 1, 3, 2, 9. Here's our picture. That's our function there. I didn't label last time. I should have. F of x. Label each graph with its equation. So there's f of x. Then, though, we also want to graph the inverse. Before we get too far along, for f of x, there appears to be an asymptote where? And that's what gets the confusing part. Is it x equals 0 or is it y equals 0? Y equals 0. But when we take the inverse, in other words, we interchange the x and the y, we're going to get 0.11, negative 2, and 0.33, negative 1, and 1, 0, and 3, 1, and 9, 2. And we can graph those. Do the best you can. I know, 0.11. It's hard to do. We have to estimate. But 0.11, negative 2. 0.33, negative 1. 0, 1. Sorry, 1, 0. 3, 1. 9, 2. And it looks very similar in picture to our previous example. What's our asymptote of our inverse function in red? Jordan? X equals 0. And on part C, these two functions reflect over what line? Well, if you look above, it's still going to be y equals x. Again, y equals x, even though my line is a slight bit off. Goes from the lower left-hand corner to the upper right-hand corner through 0, 0. It's a slope of 1 over 1 with the y-intercept of 0. But as we flip over here to the next page, what we have been working with here, the inverses that we were just graphing have a special name, and it might sound a little bit goofy. We call the inverse of exponential functions logarithms. L-O-G-A-R-I-T-H-M-S. Logarithms. And we're going to be learning more about logarithms, but today we're just going to get a little bit of the basics. And if we look back at our red graphs in our picture, we can get some information about our graphs, just like we did with exponentials last week. When we look back at our red graphs, the first question says, what's the y-intercept of our red graphs? Well, we don't have a y-intercept because we have an asymptote on the y-axis. question then is, do we have an x-intercept? If we go back here, where does this graph cross the x-axis? It crosses at 1, 0. Also crosses at 1, 0. We have an x-intercept at 1, 0. Our general trend of our graph, remember we read graphs from left to right. So again, if I go back here, coming from the left, our graph starts to go in an upward direction. Both red graphs tend to go in an upward direction. We call that an increasing. Our domain of our function. Remember, domain, we're looking left to right. So when we look at this red graph or this red graph, the thing is that neither one of those red graphs touches the y-axis. And because it doesn't touch the y-axis, we say that our domain goes from 0 to infinity. 0 is not included. Another way we could state it is x is greater than 0. All the values greater than 0, but not 0. So finally here, for our range, we don't have any limitations for our range. Our y value can be anything. It can be a positive number, it can be a negative number, it can be a fraction, it can be a decimal, it could be a radical, it could be 0. Our range is all reals. And if you look back to your exponential notes from last week, I believe, what you'll see is that our domain and our range of our exponentials flipped for our logarithm. But finally here, the definition of logarithm is stated below, and we're going to have to fill that in. We're going to spend a lot more time with this definition here. But for an exponential function, in the format of y equals b to the x, its inverse function, well, remember inverse, that would be x equals b to the y, because we switched the x and the y. So its inverse function is the logarithm log base b of x equals y. So it looks pretty foreign, and again, we're going to spend a fair amount of time with this. But let's just try to practice here for a couple of moments using the definition of logarithm. So again, the logarithm, how do I want to write this here? If we had x equals b to the y, because that was our inverse, then the logarithm would be log base b of x equals y. As we look at our function, so here's our original function, the first function that we graphed. We graph this, and we graph y equals 2 to the x. So then the inverse means that we have to switch the x and the y. So it's going to be x equals 2 to the y. And now what we want to do is we want to write this in logarithmic terms. Well, now that we've switched here, what we're going to get? Log base b. Well, what's our base of our function? It's going to be the 2. Log base b. Log base 2. And that 2 is a subscript. It drops down a half a line or so. And then, if we notice here, the exponent is what this logarithm equals. I'm going to put equals y, which means that we need to put our x here. And we can do that again on part B. The inverse of this exponential function, well, once again, it's going to be y equals 3 to the x, is what we originally graphed. Then we switch the x and the y, so it becomes x equals 3 to the y. And we want to put that in logarithmic form. So this time it's going to be log, what's our base? 3. Log base 3. Our exponent is y, so we're going to set that equal to there. And then we're going to put our x here. So to finish here, if we go back to our examples of 5 and 6, we can go back and label. What we did on 5 here, and there's a little bit of space on your paper, not much, it's probably more beside your table, but what we did on this one is we graphed log base 2 of x equals y. And on 6, again, don't have enough space, I'm going to write it underneath the table. You can probably fit it beside. This is log base 3 of x equals y.